Good afternoon, one and all present here. Today we have our speaker, Dr. S.R. Balasundaram, has been working since 1987 at the National Institute of Technology, formerly known as Regional Engineering College, Tiruchirappalli. After completing MCA from PSG College of Technology, Coimbatore, Dr. S.R. Balasundaram has joined REC Trichy during 1987 as computer programmer. He has completed his Masters in Computer Science and Engineering during 1992. Currently, he is working as professor in Department of Computer Applications. Sir has completed his doctorate in e-learning and assessment from NIT Trichy. About his publications, Sir has published more than 40 papers in reputed journals and proceedings of international conferences. Dr. R. Balasundaram as an expert in web and mobile technologies, cognitive sciences, and e-learning technologies. He has authored a book and co-authored 4 book chapters and edited a book. He has handled many different subjects like object-oriented programming, analysis and design, software engineering, internet and Java programming, web technologies at UG as well as at PG level. He was associated with computerization of national level admission process for MTech counseling during 2010 to 2013. As head of CSG during 2012-15, was involved in planning and implementation of Wi-Fi for hostels. He has held the post of Associate Dean, Research and Consultancy, and involved in the activities related to Teaching and Learning Center and Digital India during the year 2015 to 2017. Apart from this, Sarah has been coordinator of NITT and conducted various workshops, internship program, and procured equipments. He is a member for a Center for Entrepreneurship Development and Incubation CEDI under aegis of Ministry of Communication and Information Technology, Government of India, was head Computer Applications Department during Jan 2017 to December 2019. I welcome you, sir, for handling this session.
Thank you. Thanks for the introduction. So good morning to all of you who have gathered here for this event. And this topic, today's topic is going to be on an overview of IoT. So before I start, I would like to tell 2 things. Number 1, first of all, my thanks for giving me an opportunity for spending some time with you. The second one, the other side of that, though this topic is about the highest level of connectivity, IoT, there may be some small issue in getting disconnected. So kindly be patient if the system is getting disconnected in course of time, but within 5 to 6 minutes, maximum 6 minutes, we can get connected back. So coming back, so I'll go to my this thing. Kindly inform other is it visible?
Yes, sir, visible, sir.
And you are able to see the movement of the slides?
Yes, sir, of course.
Yeah, fine. Thank you. So this session is on giving a broader outline of IoT. What are the design considerations that we have to think of for this already emerged paradigm? For example, though the terminology IoT is looking very great, according to Mark Weiser, we should appreciate that when a motherboard can have so many things embedded, connected, Next level, when a computer can be connected to printer, why not things? So this was the greater thought of people like Mark Weiser that has led to different types of computing. In fact, during 2000 mid, it was a new wave coming of giving different types of computing paradigms, all emerged from networking, then distributed computing, but making some of the essential components in a more abstract way. Now that abstraction has come into limelight or higher level, that's what we call it as Internet of Things. Or in other words, when the buzzwords like ubiquitous computing, pervasive computing, ambient, all these things emerged as a kind of byproducts or extensions of your distributed computing, they are all because of the underlying components, maybe tiny things doing great things like sensors, RFIDs, everything. So a new field has come up under the name of Internet of Things, again dominated by sensors, RFIDs, etc., etc. So in this context, this presentation will be highlighting some of the essential things related to IoT, as well as what are the design considerations with respect to various applications. One of the basic definitions given by IEEE IoT, in fact, this definition is being revised now and then to accommodate more features in that concept. You can see that according to 2014, many things are able to be connected. These are across from desktop to a normal application to everything. So simply they call it as thing. Anything can be collected and state of thing can be changed from anywhere, anytime, by anything. So to make this in a better way, let us assume we have a machine in an office. Assume that there is an office having some multiple floors. Maybe in every floor we have a kind of coffee machine. Assume that there is no connectivity. So what is the process? Anybody can, instead of going to a kind of tea shop or coffee shop outside of the building, within the building itself, he can go to that machine. Whatever he wants, he can take. He or she can take. At the same time, there should be somebody to monitor the inventory. Like what is the consumption, whether any quantity of anything is getting down, stock is coming down. So this has to be manually checked by somebody, some operators or some technicians have to be there. Maybe some kind of error also may come inside the machine, not functioning, etc. So in that case, the next thing is defining as a kind of software-oriented approach, how we can think of machine having sensors. It can send notification to mobile or a central place. An application can be defined or an app can be developed. So these kind of thoughts are coming as a next level. Still, it can be improved like, see, instead of going to every floor, everything coming to a centralized place where other details also can be connected, is it possible to know in advance and based on that whether any kind of services can be done? What is the optimization we can think of, etc. So slowly, as you know that from manageable, optimizable to intelligent level, how we can provide more facilities. Say within the office, outside the office. So within the office for servicing the people, as well as the technicians, as well as within the office for knowing the other details like billing, etc. Now this can be extended to the suppliers of coffee beans, chocolate powder, or etc., milk powders, etc. So slowly it becomes a kind of expanding your connectivity, expanding your process to various concentric focusing outside levels, starting from simple thing but going to a big level. So this what a simple thing that we can achieve in Internet of Things, starting from local level to a global level. And you can see that almost every, whether it is top or moderate industry, they started investing more on this IoT for the benefit of various segments. So you can see that now, whenever this has to be accommodated, certainly a lot of devices will come into picture, device-oriented activities will come into picture, and this is a past statistics taken that by 2020, we are expected to have so many billions of IoT devices. The number is really huge. And because of this, a lot of commercial benefits also can be obtained. There is a small jerk here. There is always a kind of people to accept changes. It's human psychology. You see, everything started with RFID only. Whatever you are talking, they're all outliers of RFID only. How can I accept this? Whether this has come from RFID or this has to use RFID. Again, hen-egg problem only. This egg-hen problem is there in most of the situations in IoT also. So some of the basic things that happened, we can say that 99 Ashton could give something called Internet of Things based on the motivations he got from earlier activities. And from there, D2D, device-to-device communication, as already told, device-to-device communication is nothing but a computer talking to different types of printers also. A microprocessor talking to a weighing machine. So these things have already come, but in a different flavor. As well as you can see that how we can identify an object. See, identifying an object is if you think calmly, what is the evolution of identifying something? With respect to computer science, certainly with the great support of electrical and electronics engineering, you can always see that a lot of things are there available to address. Whether it is a file to be addressed, or a location to be addressed, or whether it is a kind of URL or URI. And now people are going to higher levels called IRI also. So where from syntactic to semantic level identification are possible. Anyhow, with respect to this IoT as a good turning point, a new object identification scheme has been introduced that has given a different direction, and a lot of projects came into picture to support this. And the concept of networking of tags emerged. When network of computers can be done, why can't we think of network of tags, RFIDs, or network of sensors? All these things, see, every minute level getting enlarged, you can see that so many new directions coming into picture. And you can see that promoting connected device has become a kind of issue or a kind of thing to be challenging one. And we have got a lot of things happening thereafter. So maybe this is one kind of evolution we can think of, from RFIDs, connecting all sensors to as a kind of networks, involving some kind of cooperation between objects, how they can interact, communicate. Then to, based on this connectivity, whether we can predict something using the big data and other aspects into the picture. So now small becoming the super level kind of thing with respect to every stage improvement. And you can see that a lot of definitions are there. Some of the notable definitions alone are given here. It started from AutoID Center, network of internet connected objects, uniquely addressable based on communication protocols. From every definition, we can gather some points. Maybe from ITU, we can see that interconnecting both physical and virtual things, interoperability based on communication technology. And if you see Forrester, he focused on how well this can be expanded for societal level and all types of applications. Maybe another term called cyber physical systems maybe coincided with this, or we can make it as a kind of synonym for IoT. There also we think about connecting everything. And IETF comes up with a more specific level, like seamless communication and contextual services. That's more important. Anything can be done or serviced, but it should be based on the context and some kind of recommendation based on sensors, mobile phones, and other devices. Then as you know, it is a consistent definition from rather IoT that self-configuring, adaptive, complex, all these things are coming up. As our Bill Gates told, we are creating a kind of DNS. You know, DNS is a domain name system for internet, but according to him, it is digital nervous system, whereby you are able to connect the entire digital world through this kind of connectivity, starting from sensors to higher levels. In fact, from sensors to sentiments, we can have a bigger scope of connectivity with respect to technologies. Okay, we normally talk about something called things. Maybe this is a good approach. It started from machine to machine with people, now people to people. There is one more thing also, again machine to machine. We started with the machine to machine at a lower level, but now the recent machine to machine level, which is not given here, is that you can think of two humanoids or two machines. See, maybe a saucer game can be played between a robo as well as a kind of artificial ball. An artificial ball and a robo both of them can play with each other, where the ball also can be having some kind of intelligence. Of course, it has come only with respect to some kind of some level on especially gaming and other domains. So things here we refer to objects. We want to get connected, get some services done. They should be readable, recognizable, locatable, and addressable through various information sensing devices, controllers, at the next level through internet, whatever may be the type of course, this scalability matters. There may be a question that whether for small thing also says, for example, nowadays we are having a lot of games. We have to appreciate IoT related projects and games are coming up, a lot of things. Do we need to worry about all these things? No. It is a kind of small portion taken from every aspect. From a kind of miniature to mastery level, we can think of any range. So that is also a kind of another term related. Can we call this as Internet of Everything? Okay, you can call it, but we make it as a kind of Internet of Things, referring to digital things and humans. Digital, as you see, kind of things related to laptops, mobiles, interactive TVs, then any kind of moving devices. And you can think of things. It can be a kind of a door, or it can be a kind of that door can be a home door, or it can be a kind of a car door, or it can be even moving a car, or it can be related to a kind of what is it? A kind of power supply, a generator. So things can be linked. Your table also can be used for displaying some information. Instead of going to a kind of separate TV or something like that, we can make use of a table or our wall to get the features of all display mechanisms, but a lot of characteristics to be defined. And for personal reasons, we can think of Google Glass, a kind of wearable things like shoes or sneakers. All these things can be thought of, watches, smartwatches, etc. So things, objects, that is digital objects and humans, they can be part of this Internet of Things. Is it audible? Is it audible?
Yes, sir, it is audible.
Yeah, please. Kindly bear. At times, I'll be asking this to ensure, because we are in a new platform. We are in a totally new platform. Okay. So, if you have a kind of overall study on the existing IoT applications, they can be confined to some 4 or 5 models, starting from simple level to higher level. Uh, they all vary with respect to, or scalable with respect to, who is initiating, from where we have to collect the data, what is the connectivity, where it has to be stored, whether we have to go for high-end storage like cloud, or locally they can be managed, whether computations are less or more. So based on this, all the existing IoT applications, whether it is simple or moderate to high, they can be classified. So in this case, if you see a kind of small application where uh, I want to see whether that is I can control the switch on or off a bulb on electrical system, you can use of a kind of thing where a single node or device is enough. Everything is done with respect to sensors with local capabilities for low cost and low complexity solutions. Data is not much and not involving intensive computation. This is one way. This is the base for defining a kind of smart home that can be extended. When I enter my room, that time only I want all the bulbs to be switched on. Or when I can exit from the lab, automatically all the lab switches, everything have to be switched off. Then we can link to other things also. Because many times we forget to switch off our systems or fans, etc. when we exit the room. So how the doors can be given a kind of control over these kind of applications. Then if we see the next level, where it can be thought of for a kind of small level farming, a kind of irrigation, a kind of small monitoring of garden to something extendable way. It's enough we have a single node, maybe for continuum of the process, to know that what happened earlier, all those things. When the data storage is more, we can push this to cloud. Of course, before cloud, we can think of a kind of a database or something like that. Now in cloud also database, but this is a separate model. We can think of directly going for cloud-based model. Uh, Moderate, simple moderate to even more data also can be accommodated when it goes to a kind of higher level irrigation system. Uh, the analysis, like what happened when it got switched off, um, whether any other observations can be thought of. These kind of computations can be done locally also. In fact, this model 2 is simple to moderate. And if you see this kind of thing, where a kind of tracking the packaging. Say, for example, if I remember one thing. 3 years back, there was a kind of IoT competition happened, and the best prize has been given to a kind of application um, where they where they focused on these kind of things. Like um, you have to transport heavy package of seafood from east to west. This in our country only, from India. From Kolkata to Pune, they had to transfer seafood from one place to another. And as you know, the conditions of seafood are very critical, that they are highly susceptible for changes. They should be taken care. Though they normally, any kind of such carriage will have some kind of protection. But this protection mechanism has been done with multiple levels. Like, this is the starting time of the truck or the what is it? Vehicle that's carrying this food from this place to that place. This will take this many hours, and these are all the places where they are supposed to halt. Approximate 1 hour or 2 hours here and there may be there, and the temperature outside may affect the vehicle also. In turn, it may affect the internals of the vehicle also, in turn, etc., etc. So a kind of IoT model has to be developed, taking care of the internals to external using GPS. So this has been given as a kind of award. This is just a small gist of that. So in that case, whenever such kind of applications are there, you can think of a single node, data stored and analyzed in cloud-based application, but data is more intensive, and more analysis and computations are more have to be done. In fact, it links a kind of Uber computation with internal computation. By Uber computation, you know that to keep track of whether the Uber driver is going in the designated track once something is allotted to him. So these kind of hybrid or layered approaches are coming, things will get changed. Then another thing, as you see, which is heavily based on how the air quality is changing, how it is affecting my traffic, how to measure that, how the sound is polluting the system. So in that case, a lot of pollution control related activities, IoT related applications can be thought of, measuring the air quality, sound quality, rather noise quality, etc., etc. So here, slowly you can see that multiple nodes are needed for local analysis, all cloud-based only. But slowly, one more set of nodes are coming. Other than local nodes, some observer nodes are also, because we have to take at different places. It is like even the previous case also, when the application goes at a higher level, observer nodes have to be more. But here, the justification for observer nodes are certainly more. So in that case, for a city covering, say, 50 kilometers range, a city, you should have observation at different places, and you should do some kind of statistics to proper statistical mechanisms to declare something that this is what happening like that. Suitable for multiple nodes, more data, certainly intensive computation, data and analysis. This another thing where you can think of disaster management or crisis management, how you can think of IoT, whereby certainly multiple nodes are needed, maybe predetermined. As you see, I saw one of the things in National Geographic Channel, um, where you might have also seen that how the animals react to some kind of very critical situations. Of course, they would have embedded some kind of sensors or something like that. And when some kind of panic happens, where they go, how they go, can it be modeled? See, a single outcome coming from a kind of heterogeneous thoughts. So in that case, multiple end nodes and one coordinator node, whereby sensors, actuators, everything deployed. The coordinator collects data from end nodes and sends to the cloud for processing. And here, suddenly the concept of the sensors being grouped together, that is wireless sensor networks, play a dominant role to pass the information. And especially if we see this article, though it is a very old one, it's a very good article. A lot of insights you can get from that. From simple sensor to a kind of how AI and data analytics can be applied. A lot of scope for improvement can be seen in this document. We can also see that how this can be further extended for the kind of weather forecasting. That's what we are seeing now. Multiple independent end nodes. In fact, it is almost like trying to predict the, your predictions are always good. It is almost we are trying to, having told the cloud, you are trying to reach nature also. Nature's predictions is very difficult because our predictions algorithms, they take care of only limited set of features. The features are more important for prediction, and certain features are always pervasive. Anyhow, for high-end models, you can think of better IoT or high-end IoTs happening. So from these models, what we can say that this can be properly categorized into a kind of layered approach. So as you know that before OSI reference model came into picture in networking, several people were working here and there. But finally OSI became, or its proof of concept became the highest level, accepted at, by a larger people. There were a 4-layer model, 5-layer model. I'm not talking about 4-layer model of TCP/IP earlier, but the proper segmentation. See, in any design, there is a very important thing like separating the concerns. It is a philosophical term, but very much important for any design. How well you separate the things, but you are trying to integrate them, work them properly. By separation, are you losing anything? Certainly by integrating or by tightly coupling the things, no doubt there is going to be some kind of issues. So they should be loosely coupled. At the same time, they should be properly interfaced. So the power lies on interfacing in negotiating these two things or many things. So in this case, for IoT also, we can think of one such layered approach, and the best model is given by Cisco. This is only a kind of miniature. I like this article given by Sukanya Mandal, where building blocks and architecture have been well defined, starting from sensors. Is it audible? Is the screen visible?
Yes, sir.
Yes, sir.
Yes. And as I already mentioned, there is a possibility that in between, at some point of time, it may get delinked also. But again, it will be resumed after 5 to 6 minutes. Coming back. Sensors, they are the source of this entire discussion, front end, to collect data from its surroundings, give out data to its surroundings, how to be uniquely identified devices, with unique IP addresses so that they are locatable or identifiable, addressable, etc., etc. And you see that there are plenty of sensors. All of you are aware of that. They can either autonomously, they have their own, or they can be controlled by some other center. A lot of sensors are there. It is our duty to choose the sensors. If it is a kind of vehicle, what are the sensors? If it is a kind of airplane, what are the sensors? If it is related to animal monitoring, movement monitoring, a kind of sensor. Or if it is a static thing, like a kind of plant or something like that, a kind of sensor. So depending on the type of models or applications, the choice of sensors play a better role. And actuator, it does the reverse. Taking electrical input and turns into a physical action. You've got different types of actuators for defining the motion of objects or elements in a straight line, or rotation movements can be thought of. Relays, where electromagnetism kind of things can be judged, coming from various sources like lamps, heaters, or any other vehicles, etc. Solenoids, which are mainly used for home appliances. So we can think of where when somebody is knocking the door or pressing the calling button, that button, they are pressing the button, calling bell, that can be notified wherever I am, in the kitchen or in the dining table or in study room, with respect to any specific device or any device nearer to me also. Instead of fixing the device that from this device only, already calling bell is for that only and the receiver is for only. But based on the movement, the nearest device or target should be searched. Small algorithm has to be written for that, so that this calling bell noise can be given to that device so that I can understand it. A kind of ad hoc, many kind of ad hoc network to next level can be thought of through actuators. And we have got plenty of things. So these sensors, what they do is they get linked to the next network. The purpose of these sensors is to collect the information and pass on the information to the next level, namely your gateways. So before gateways, there are certain processors also. You see, processors with the sensors can be combined. They take care of all essential activities. They can be real-time based, or it can be dynamism based, or it can be static based. You can think of this processor taking care of so many other layers also, like security checking, privacy checking, etc., etc. The sensors combined with processors will communicate to the next level called gateways. So for us, it is things only. We are using the things. Sensors collect the information according to the situation, and they give it to gateways, which are transformed to various levels of networking. They're all for routing the processed data and send it to proper locations for utilization. Both way communications can be possible, and there are plenty of ways in which LAN, WAN, personalized area network, or virtual private network, so many things can be thought of depending on the context. So in fact, we can think of better storage devices connected to this device, storage aspects. When the sensors also can store there is a limit. They can stream the data and store it someplace, and those data can be leveraged to the next levels. But all these things are taken care by protocols As you know that protocols, they help in each and every stage to smoothen the process. So what are the protocols? Broadly, they can be bus-based or agent-based. Mostly agent-based protocols are dominating now, starting from Bluetooth, Zigbee, and WAP, Web Transfer Protocol designed for mission-to-mission application. These protocols, they can take care of physical level activities, communication level activities, data transfer level activities, or with respect to device, how they can be managed, etc. For again, based on the 5 or 6 models told, you can choose anything, or you can make it one as a permanent, whatever it is. So this management service layer, it has got a kind of operations support service that includes device modeling, device configuration, all device related things to link to the earlier stages. Of course, as we mentioned in the first example of coffee machine, when you want to connect this to other things like ERP or customer relations or a kind of milk powder vendor or supermarket linking, billing, this kind of other applications also can be managed in this context. A lot of applications are based on this. So coming back, this is what we told. This is a layered approach where starting from sensor, we've got devices connecting the data from various sources, smartphones, PDA, bridge, or anything, router, all these things deployed to transfer data to the next level, etc., etc. So many levels for management goes to various hubs, switches, routers, gateways, finally to the application level. Of course, this is only a kind of abstract set of layers. This can be further extended also. And based on the smart environment application domain, because IoT is now moving towards smartness, rather kind of intelligence to be deployed, every stage, whether it is sensor stage or networking stage or kind of what is it, connectivity, then communication, everywhere, interaction method, everywhere you can think of range of things happening. And according to your smart application, whether it is office or transportation, say for example, I would like to know which will be my parking slot after 1 hour. When I have to reach a particular destination, after some time, what may be my parking slot? That can be designed, a kind of logistics can be thought of. Then smart city, which is the prime objective of today's activities, and it goes up to very larger applications like smart military, etc. Accordingly, you can think of high-end components to be chosen. Now, this segment is more on how we are going to think about the deployment activity, how we are going to develop, what are the things. I'm not going to tell taking about a Raspberry Pi and other things, coding. I am not going to the minute levels of that, but the components, next level components, etc., like that. How we are going to develop IoT application, who are the stakeholders. Writing a program for adding 3 numbers was a great task earlier. But now, we have come to a level of building very complex applications of smart cities. But the problem is, when it was a small problem or a kind of moderate application, one-to-one concept was there. For doing this, to choose this. For this task, choose this. But now it has become a kind of pushing us to a kind of supermarket to buy something. So many products satisfying the same requirements, different colors, shapes, sizes, vendors. Sometimes become a kind of guidance is needed, which one to be chosen. So in that case, this discussion is on what are the things available. Basically, this platform, most of the current applications, those model 1 to 6 or whatever it may be, especially we go further, we see that when cloud has to be made use of, go for either Azure or AWS. Each one has got their own plus or minus. Of course, IBM Watson, it started, a lot of advantages are there. Similar advantages you can see each and every place. But depending on the requirements, like not only the cost involved, but also the way in which the data is collected, analyzed, within brackets, secured. That is separate branch of study, how it is scalable, etc. You can always choose the required things, but we have to start. Some platform may tell that you have to go for this hardware, this hardware. Some may tell that I am coming with a hardware, don't worry. Just I am giving a login password, you enter, pay this over. So these kind of things may happen in some kind of thing. So depending on the cost effectiveness also, this deployment platform can be chosen. Operating systems, earlier we know it was MS-DOS, then we had only few operating systems. It was Unix which made a complete breakthrough. Yeah, I'm continuing. As you know that Linux, which is based on Unix, has done a complete turning point for so many things involving multitasking, multi-threading, back-end processing, etc. And the ability of Linux is that how well you can reuse the existing things to extend further. That's what happening in almost all the applications, the power of Unix. So a lot of operating systems based on Unix available, but more specifically Riot for low power devices, Quantiki, again it is open source. For high-end even IPv6, IPv4, it's also good. ARM model is based OS is well supported for IoT, and this list is a very big one. A study on what are the things available, why it becomes a survey paper, and that too with respect to the IoT application, taking 3-4 applications, which will be better. Why something has failed? That will become a kind of good outcome. Raspbian is also a kind of widely used based on Raspberry Pi hardware. And coming to programming languages, see, finally what we need is data is collected, transformed. Now data is available in storage devices. They are given to next layers through communications, enhanced by protocols, etc., etc. But next, we have to how to do this program. That program can be making something on or off, or giving some kind of alert. The program outcome can be anything. It can be a kind of recommendation, or the program outcome can be a kind of clustering, which are all affected here, which are all not affected, which are partially affected, a kind of classification. So there are plenty of ways in which you can think of choosing the programming language. But one important thing to be highlighted here, maybe I am out of track. I am suggesting this also. There is a changeover because of Python. But let me humbly tell that let Python come. Other thing also will come in another few days. Something else, Julia will come, something else will come. But let us try to understand the power of C. Still, we have taken classes, we have written applications on C as well as C++. We have not explored, we have not digged much. Because if you take C, C is actually meant for talking to the internals, peripherals, devices. When people were struggling with Zilog microprocessor related applications, they wanted a supporting hand called C. Again, credit goes to Unix laboratory. So that the C language is called a dawn language, D-O-N, a dawn doing good things, underground language. C is meant for that only. If I tell I have written a program in C for summing the numbers 1 to 5, or telling that I have written a program for an application to reverse a string, okay, they're all okay. A lot of header files are there. Even I can tell that I have written an employee information system using C language, okay. But C has to be maintained. That's what, if you see, many companies, especially involving mission critical and safety applications, they are using C to a greater extent, and IoT applications, I humbly request C to be there to some extent. The way in which C programs written for mission critical and such IoT applications are totally different from what the programs I used to write. They are totally different. So coming back, like C++, because of its ability to make things as objects. Now the objects what we talked in the beginning, things are like physical objects. The same physical objects, you can make them as programmable in terms of classes, objects, and talk to each other. So in that case, C++ and Java can help you how object-oriented way IoT applications can be developed. At a lower level C language, but when you define as an object-oriented way, C++, at a higher level, Java can help you, especially with respect to J to ME as well as J to EE. You have a lot of facilities for IoT applications to be developed. JavaScript is preferred by many because of its simplicity, because finally any outcome expects a kind of simplicity. That's where the cream of that product lies. Abstraction is important. So JavaScript abstracts so many things for internet applications, because now we are landing all these things from a small switching on, door opening, or door alert system, something like that. We are making that as a kind of big system, naturally WAN, internet, all these things to happen. So JavaScript is suitable for writing quick applications. Python is no doubt is coming up. It can be used at a higher level where your analytics can be thought of. Again, with respect to the coffee machine, can I suggest a new product to this person? Can I alert that person today he has not taken the coffee? Can I give you a mobile alert? Is it time for you to take coffee, like that? For this kind of alerting, analysis based on past historical data, or showing some kind of dashboard, how much time has been spent in taking coffee. A dashboard kind of visualization can be provided to the needy people or unwanted people, whatever it may be, through data analytics. For that, you can think of Python. Of course, depending on the domain, we see a lot of papers or a lot of applications using Go, Rust, Parasite, Bhash. So many things are there. There are certain groups developing languages for IoT alone. Set of people doing that. A lot of open sources are there. In fact, kits themselves are there. Ready-made, like integrated development environment. You have Home Assistant, Device Hive, Arduino kits, plug and play. You buy that, you can do everything. It's a container having all the facilities, just to plug and play. So up to this, they're all covering different aspects of how to develop, what are the supporting features for your product. Now, if you see the IoT application, especially higher level models, we told, when data is pushed to cloud and more things are to be done in the cloud, more data to be developed, very quick responses have to be done. The communication model plays a vital role. I'm telling data communication, process communication model, the models play a vital role. Broadly speaking, we have request response, publisher subscriber, push pull, and exclusive pair. Mostly request response, publisher subscriber dominating in the industry, push pull coming up. Push pull coming up. Recently, I saw one application where depending on the what is that location, rather time, depending on the location and time, songs coming from the vehicle or our car. An automated car, IoT enabled car, depending on the situation, or it's a morning time or morning related songs. If it is evening related songs. So the content, how it is related to the context. So in that case, you can see push-pull mechanism highly useful. And some occasions, exclusive pair also is being thought of. As you know that request response model, client sends request to the server responses. And starting from networking, we have this coming to a greater extent for any kind of e-commerce, m-commerce application. And for this, a lot of background things are also how to be done. We should think of a kind of thin client and fat server. Server doing most of the things, connected to other resources, etc. Like keeping track of the logs, connected to the resources, modifying the responses based on the request, tailor-made responses, etc. Here, HTTP comes as a kind of a prominent protocol, as you have TCP/IP, which normally we see in any kind of banking activity or ticket booking activity, etc. Published subscriber model, which you can see in recent applications in e-commerce also, that is in anticipation. You publish something. Your application, whoever wants, they can get the required things. This is there with respect to traffic monitoring IoT applications also. Say, for example, somebody is giving some data about the traffic for another 300 kilometers. For every 50 kilometers, they're all recorded and they're all stored in a cloud. And that data I can get. Now, when I'm moving, this data can be useful for me for the vehicle to do some different directions also. So somebody is publishing some activities with respect to climatic conditions. and the user who is traveling, he is connected to that. That is, the car vehicle uh, computing logic is connected to the already available sources, and based on that, some kind of alerts or some kind of things can be given to the driver. This is what we call as a web service model also, middleware or web service model also. Push-pull model is coming up in entertainment-based IoT applications, where the data producers push data to queues. So this is happening in, we don't know the queue time and the queue waiting time and the queue length, all those things, they're all hidden. And good research work is being done in push-pull model, especially queuing mechanisms. The appropriate queuing and parallel queues to be taken care to speed up the results. Of course, the separation of concern, like producers need not be worried about the consumers, the reverse also. Especially when you see some kind of YouTube things or any kind of latest recent things to be seen, everybody will be giving a lot of queries to the Google. How it takes care of. A part of push-pull model is also needed to support this very high-end intensive requests. Exclusive pair model is a kind of authenticated small domain, work very nicely. Maybe we can think of for a kind of small irrigation system, home automation, a transportation management with respect to a limited campus. So for such designs we can think of. For our campus, we want to suggest what is the place for this vehicle to be landed. So exclusive pair model. Only those users, and like that we can. So this communication again, so we have two broader APIs coming into picture. One is REST-based and WebSocket-based communication APIs. Highly useful for IoT communication, not only IoT, even for any e-commerce application. So REST-based communication API, you can see this paper also, well given, great article, I liked it very much. A REST-based industrial web of things framework for smart warehousing. You think of warehousing, see, in case of e-commerce, somebody has given some order for something, but from where it has to be shipped, whether from manufacturing or from dealers, how to contact them, etc., etc. So this supply chain, can be well handled through REST-based communication APIs with some constraints. Of course, there are some constraints like client-server constraints, stateless, that is, each request from the client server must contain all the information necessary. At any point of time when somebody is asking, we should be able to link the chain properly, a kind of a relay race. There are two types of things. Certain often required data should be cacheable. Certain long computationally dependent data can be stored in some other places also. And everything goes as a kind of chained layered system. So this is what a prominent one, followed by Amazon, Swiggy, all those things. Of course, now we are having Swiggy people coming a kind of manually, but it can still have a lot of intermediate stages for part kind of IoT also. IoTs in parts, then integrated as a high-end IoT. The rest is more popular IoT communication APIs based on HTTP, but HTTP has a kind of problem. So though we have come up with a lot of e-commerce applications served by HTTP, because of dynamism and real-time because we are very greedy. I want everything immediately and like a kind of magic. So magical things have to take place. Still, the research has to get upgraded. Of course, IoT is here to satisfy some of the magical things. As a next level WebSocket based communication can be thought of, it is a bidirectional full duplex communication between clients and servers. The issue with respect to HTTP may be avoided here, especially low level latency requirement with high throughput requirements can be thought of. That's why I told the entire IoT application can also be modularized so that individual segments can be well defined through a part of API, and WebSocket based API is the best approach that can connect to other things. It reduces the network traffic and latency, avoiding overheads of connecting the setup and termination. Whereas HTTP has got that. That's why it is chosen. For real-time interaction or real-time transfer or streaming of data, HTTP and REST are not the best suited protocols. So go for WebSockets. WebSockets should be chosen. So I'm almost coming to the closer. That it started with RFID. In fact, from chips only, and chips can be assembled and we can think of a board giving great abstract outcomes through a computer or any mobile device. Connecting these things through machines took place. Now to smoothen the connection, so many stakeholders have come up. So there, your cloud takes a greater part as a major stakeholder, where data intensive, communication intensive, computation intensive things can be well taken. So with this, I stop. So before I conclude, I would like to tell that we started with a kind of coffee machine to understand without connectivity what are the issues, how layered level it can be improved with limited sensors in one floor to sensors data giving next level data to the other stakeholders under a big umbrella. Various models are available, can be categorized with respect to their intensity related to data computation, storage, communication aspects. So in this context, a layered approach is necessary from sensors. Then we can think of the processors, gateways, the communications, etc., application. In the application level, you can go for a lot of analysis as well as analytics to be done. So for this, you need some ingredients, whether it is from operating system point of view or sensors point of view or communication point of view. You've got plenty of options. Rather, you have to make it from problem of plenty, you should bring positive from plenty. A positive aspect from plenty has to be brought out. And from this diagram, which I liked from interdigital, the whole model is becoming a kind of 6 cube, where connectivity, collaboration, cloud, all these things are important. Content and context. Content is important. Next, context is important. But at the top, smartness, that depends on both context as well as cognition. context combined with cognition will lead to better IoT to take place. That's what I told. It may look IoT is like a kind of magic. Of course, you might have seen a lot of examples of this. The best thing you can think of how your Iron Man is able to get data just by touching something, and he is able to enter a different world of his thoughts or their thoughts. In fact, it was a good article where they told virtual IoT. I could get some details about that Avengers Endgame, that movie. There, they have done a lot of research on IoT also, virtual reality, IoT, etc., etc. And there, one term was very much interesting: virtual IoT. So that has given a lot of opportunity for cognition becoming part of IoT. Here, there is a red dot shown cloud. See, all other things are having two ends. They look static words, but varying. Now that red dot is, as of now, it is cloud. In future, it may be anything also. So that is a varying one. It can be for computation, storage, or anything else. Only that part you can vary always. Okay. So finally, what happens? This cartoon I liked very much. I can give directions to everything, every piece of object. All of them will sincerely do something. At the same time, they will also start analyzing me. Machines start thinking about me and analyzing me. So in that case, one of the major constraints or considerations for IoT application is that whether they are secure. So in that case, what is security to be thought of? Sensor level? How? Processor level? How? Operating system level? Which operating system is more secure? Do you have anything separately secure to C? Yes, secure to C is there. It is there by what is that? For mission critical systems, they use that secure to C. When Alice and Bob are communicating, I want to say X is a variable int X. Let us assume int X, which is to be shared by Alex and Bob only. Instead of me doing something, storing something in X, sending to from Alice to Bob, and worrying about all those things, cryptography, everything. Secure C, it takes care of int within brackets Alice to Bob X. It means X is an integer type variable, and the people who are able to access Alice and Bob only. And according to this direction, Alice can send, Bob can receive. Whenever any modification for X is done, that is, Alice is doing some modification, Bob can receive it. So this is what secure C. So coming back, security has to be given more important with respect to the language chosen or the processor or database. Okay, I was sent data, but the data coming from distributed nodes to this node, common node, centralized node, whether it is correct, whether it is secure. So from LAN to internet, when it goes, are we deploying LoRaWAN? What are the other technologies, etc., etc. So security threat is higher. We cannot be idle. All things are doing good. All other IoT things are doing the greatest things, but we should move to the next. So with this, I conclude my talk. So, is it audible? Any kind of
Yes, sir. Audible, sir.
yeah, any kind of
Participants, if you have any queries, you can unmute and ask, or you can post it in the chat box.
So I thank, of course, questions you can ask, but to fill the gap, I am talking. It is not by telling thank. I thank the PPT is itself is a kind of Internet of Things only. It is taken from all the things taken from Internet. They are arranged in different forms. So things are available. We have to work with them. And for people who are IoT researchers, they should start simple by experimenting with some kind of IoT product and seeing the limitations with respect to communication or context. You can always contribute more. Any question?
Sir, no questions, I guess, sir.
Okay. Okay. So I thank Dr. Sitaraman, the organizers, the director, and AICT for all, especially the institute for giving me an opportunity. And last but not the least, you see, I thank all the participants. The more you hear, you are moving to the next stage. So I thank all the participants. We all work together. Thank you.
மெயில் போட்டுக்கோங்க. இன்னைக்கு காலையில ரவிச்சந்திரன்.
Okay.
Sir, thank you for your session, sir.
Thank you. Thank you.
It was really interesting and informative, sir.
Okay.
On behalf of IIIT Management and Department of EC and CSE, we thank you for your session, sir. Thank you. Thanks a lot. Sir.
Thank you. Thank you. So shall I close?